Samsudin sir, shall we start, sir?
Yeah.
Yes, sir. Madam, Sudha, madam.
Okay, sir. Often the things that happen to us are preparation for the future and for a greater purpose. Have a positive Friday. Wishing you all a very happy and pleasant morning to everyone present here. It is indeed my pleasure to welcome you on the behalf of SRM Institute of Science and Technology for the Day 12 2 weeks online international faculty development program on the era of change, recent advancement of machine learning, terms of AI and IoT, organized by the Department of Computer Science and Applications. Now, I invite our dynamic Vice Principal, Admin S&H, Dr. J. Dileepan, to deliver the welcome address. Please, sir.
Thank you, madam. Very warm good morning to all. It gives me immense pleasure to welcome you all to this day 12th of this 2 weeks online international faculty development program. First, I would like to extend my hearty welcome to our chief guest, Mr. Samsudin, Senior Engineer, IoT, Infosys Solutions, Chennai. Thank you for accepting our invitation, sir.
Thank you very
So
much.
the topic of the today's session is introduction to exploratory data analysis in IoT data. The primary objective of the exploratory analysis is to examine the data for distribution, outliers, and anomalies to direct specific testing for your hypothesis. And also it is a very important approach to analyze expansive number of data, like data generated in real time by IoT devices. So many organizations can use these facilities and getting more benefits such as optimize operations, control process, automatically engage more customers and empower employees. And so the today's session will be more helpful for the research scholars who doing the research in this area. So once again, I welcome you all to this wonderful session. Thank you.
Thank you, sir. Now, I would like to invite Mr. D. Rajkumar, Assistant Professor, MCA, to introduce our chief guest.
Good morning, everyone present here. It is my immense pleasure to introduce our resource person of the day, Mr. Samsudin. Mr. Samsudin is working as a senior engineer in IoT in Inspire Solutions Private Limited, Chennai. He has 10 years of experience in research and development projects in the field of embedded systems and IoT. Throughout his career, he has been involved in multiple phases of product development lifecycle. His skill set includes Python programming, backend development, embedded programming, embedded hardware design, and data visualization analytics. He is graduated in BSc Electronics and Communication from Anna University in 2010, and he has completed his MTech in Embedded System Technologies from College of Engineering, Guindy in 2021. His recent projects are focused on industrial IoT applications using communication protocols such as Modbus, RTU-TCP through Edge Gateway. Mr. Samsudin has also involved in variety of other applications development, including health monitoring of power transformers, health monitoring of manufacturing equipment, process digitization of packaging and assembly lines, performance and product monitoring of CNC machines, and asset monitoring of utility buildings. His previous works also include LED luminaire design and illumination analysis of green buildings, EMG classification of microelectric prosthetic arm, fire and food detection of refit ships, and forest fire detection using WSN sensors and drones. He has also taken several workshops in Python, IoT, and embedded hardware design. He has also guided several interns, and he has also taken care of several final year projects for the benefit of students. Sir, we are extremely very happy to have you in your midst. Now we request you to take over the session. Thank you, sir.
Thank you very much, Rajkumar. So first of all, I would like to thank you the Department of Computer Science, SRM Ramapuram, and the management on behalf of the entire Inspirasys team. So it was really a great opportunity to share our insights on analytics and IoT with you. And also I have seen the other speakers' profile, and you have like taken extra care to choosing the industrial experts for as a speaker for your 2 weeks online program. It was a really great initiative. It's going to really be helpful for the teachers who are going to guide students and taking classes in the fields of AI, ML, and IoT. Okay, so without any things, I will start with my presentation. Okay, is my screen visible?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So let me quickly explain what we are going to see here. What are the objective and what is the agenda? Okay, so the title is Introduction to EDA on IoT data. So the reason EDA is a very preliminary analysis for any analytics, data analytics project, right? But as an electronics engineer and as a people who have started working on sensors, collecting so much data through this enablement of this IoT and embedded systems. So there are a lot of data. Okay, those data are more of like we don't have a detailed metadata of these data, and they have different timestamps with a different variety of units and fields, right? So this data is most of them are unstructured in nature. And so a preliminary EDA is a must for any type of IoT data to understand the better insight of these, what the sensors is trying to communicate, and to postulate our hypothesis. Let's say if you have any sensor data from a machinery, okay, any product or process machinery, you want to identify a KPI, or you have an hypothesis that how let's say a temperature affects the production of your machinery. So this is one hypothesis. How can you go ahead with that? What are the variables you need to consider? Because when you talk about IoT, there are a lot of sensors are there. Okay, starting from temperature, humidity, stepper model. So there are so many different sensors are there. So you need to identify which are the variables which are right for my mathematical model, for my machine learning model, right? So I'm going to cover this. So please bear with me. So this kept in mind that this is a very basic session. So I'm not going to those who have zero knowledge on any type of analytics and Python. It's fine. So I have so that's why the key takeaway from this presentation is, so how to do an EDA on a data. Okay, any data. So if you are from background from electronics or electrical, fine, because this is something related to electrical data. I mean, basically occupancy data. And also for others, those who have got any type of data sets from in a CSV format of any of your data source, such as Kaggle or anywhere. So how you can just start with that before postulating your hypothesis and testing by building a machine learning model. That's the agenda. So it's more of like a hands-on session. So please feel free to open your new tab. I will explain you I will guide you throughout this session how to open a Google Colab and practice the code what I'm trying here. So at the end of the session, I have shared the whole code which I'm going to walk through this session, and the data set is shared in my GitHub profile. I will share that link also. It's a public repository. You can download that. You can try it also. So it's more of like a hands-on session. So the phase one, we will have a little bit discussion about the data analytics for IoT. So what are the different analytics are available? Why EDA is important for IoT data, which is more of like a presentation thing. Then next we will follow. We will go ahead with a walkthrough where I will take a data set and I will do a hands-on EDA exploratory data analysis of this data. And finally, we'll conclude with a little bit note on what Inspirasys is offering as a part of IoT. Okay, so yeah. Okay, so the agenda will start with analytics, introduction to analytics in IoT. We will see what are the different types of analytics and what are the use cases in IoT. And especially most of our projects and use cases depends on industrial IoT platforms. Okay, so I will focus more on IIoT. Okay, then followed by we will have a walkthrough on a very simple IoT data. Basically, it's a room occupancy data. So where a sensor, we have collected some thousand sets of data points of a room occupancy and temperature and humidity. Now we are going to create a classification model to predict whether a room is occupied or not with the given temperature and humidity data. So it's a very simple one. It's let's call it as a level 0 of any EDO IoT data. The reason I have kept it in such a way that so that anyone who has already good experience with EDA other thing, yeah, you can you can easily understand it. You can go, you can carry it. But those who don't know much about this analytics or EDA, this will be a really a good starting point for you. Okay, and the tools, the program softwares we are going to use is the Python. Again, it's an open source, and the packages we are going to use are also open source package. So there is nothing stopping you from trying EDA on other data sets which you find interesting from Kaggle or from the internet. Okay, so this consider this as a starting point for you for your EDA journey. And finally, I will conclude for the last few minutes of my presentation with an about our Inspiressa Solutions Limited and our offering on IoTs. Okay. Good. So let me quickly start with use cases. So IoT in the sense like we are generating a lot of data, right? So where this data coming from? So basically we have this standard industrial machineries and
multidimensional data views.
Hello. Sorry. Okay. Okay, so I'll continue. So this analytic use cases in the sense like we are collecting a lot of data from IoT, from industrial IoT platforms, right? So the data can be sensor data. So basically they can be like we can install some temperature, humidity, and other IoT sensors across the workspace, across the industrial equipment and machinery, and we can tap their health metrics and performance metrics data. So the other data will be other type of data source will be our machinery. Like already there are so much automation and advanced automation available with the industry, right? So basically they communicate with the standard communication protocols such as Modbus TCP, Modbus RTU, Profinet, Profibus, OPC UATAGs, right? So what we can do is we can set our edge gateway there, where this edge gateway will communicate to these their already existing systems, machineries using the standard protocol and collect the data. So these are the second type of data sources. And there is a third type of data sources for any IoT application, where we have this ERP and MES system. So where you log how much production has to be done for a day for a particular machine. So you can even integrate with your inventory management system. So things already which are digitized in a software manner. So these three are different data source. One is our sensors. We install IoT sensors there, and they will push data to our edge gateway. Number two will be my IoT integration, where I will integrate my gateway with the existing communication protocol like Modbus. And the third one will be like other software systems like ERP, MES system. So once you combine all this data, you will get a very good insight about what they are trying to tell. And you can postulate your hypothesis like how you can improve your production, how you can improve the productivity of the people, or how you can like predict the health performance of these machinery. Because in manufacturing and other places, the health of the machinery is very critical. Okay, so we can't allow this downtime to be even a few milliseconds. So we have to carefully monitor their health performance, right? So we have to closely monitor their vibration and temperature level, and we have to forecast them. So with that, we can know that, okay, it may fail in another few days or 4 days. So you can do this predictive maintenance and you can avoid those things. So this analytics, when combine all these three different data sources, then you will like you can do a lot of things with that. And IoT enables this data aggregation and consolidation and bring it to a common platform so that you apply analytics on it. So the sensors, edge gateway, and the cloud communication, database storage, visualization comprises the IoT. I mean, those are the main IoT part. And analytics plays a main role at the visualization and end part of any IoT platform and applications. Okay, so that's a very important role of analytics in IoT, especially in IoT. So what are the different use cases? So where we can use in industrial IoT, or like I have few lists with me. So we'll start with the supply chain management and optimization. So in any manufacturing industry, like that, we have several phases, right? So each equipment have a different rate of production. Okay, so that what is the key objective will be, you have to get maximized output from each throughout the assembly line. That is the objective. So how you can optimize it, because when each have different rate of production, so when you fit an IoT sensors or log their production value, then based on the how much production it has taken, you can easily, once the data is collected, you can do some optimization algorithm. You can find out at what speed each has to be run, so that you will get an optimized production rate. Okay, so then very important, predictive maintenance is one of the best use cases in analytics. So since I said there is no downtime is very important, so you have to reduce it, and also you have to run any machinery in its optimal performance efficiency. Okay, you must not overload them, and also it must not be underutilized. So in that case, what you can do is you can attach this sensors like temperature and vibration monitoring systems. on your CNC machines or milling machine, drilling machines, right? In the manufacturing industry and assembly places, and then you can monitor their values and you can forecast when it's going to run. Especially vibration analysis play a key role in CNC and drilling machines. So it will monitor the vibration observed by this spindle. From the spindle movement, you can easily learn. Even camera is also incorporated in some places for this predictive maintenance purpose, which involves machine learning and image processing and video analytics, basically. Then productivity analysis. So we have each of these machines, right? So they have something, a factor called OEE, overall equipment effectiveness. Basically, it's a combination of three other factors where they will calculate the how effective a machinery is in a manufacturing industry. So we can compute them and we can analyze them with respect to time. So how this OEE value of a machinery, or you can correlate with a friend, with a person, with a technician who is working on it, because a machine will work 24/7. So basically, it is operated by a technician on a 3-shift basis, right? So you can, when you log this productivity or OEE value of each of these machines, you can see that which person or which technician uses our equipments with the highest efficiency. So those things can be done. So productive analysis of both the machines and the employee. Then very important thing, correlation analytics. Now we have variables across different sections of an industry, right? So earlier the industry 3.0, we have this automation, embedded systems, all these things coming up. And now what we talk about industry 4.0. So it's not just limited to a one section of any industry. You are connecting multiple section of an industry, and also you are verifying your data with different plans across separated across globe. Okay, so you collect all those information, you can correlate them, see how each of them is correlated with other variables. So we have hundreds of dimensions of data for any simple process. You can see which data matters. So is there any good correlation between each of these factors? That will give you a really good insight, right? So based on that, you can identify the key parameter indicate KPIs for, which is very important. Yeah. So in simple language, correlation analysis basically here in a graph, you can see that I have two correlation. I want to see how well X and Y is correlated. Okay, what I can do is put a simple scatter plot. That's all. So in the first quadrant, you can see there is no correlation because the X and Y points are scattered across the graph surface. In the second graph, right-hand side, you can see the A and B has good linear correlation. So you can see the most of the line fit into a straight equation, right? So they have even given the R square of a 0.85. Okay, it has good correlation, which has linearly proportional, which means when you increase an A, B also increases. And similarly, we have other different correlation like negative correlations, all these things. So just by plotting this is for 2-dimensional data. But imagine we are going to, for any typical IoT simple machinery, you are going to have some 20-30 dimensional data, and you want to see the correlation of it. Yeah, we have open source tools and packages in Python that to do that, and we can have something called a dimensional reduction techniques. Okay, with that we can find out only key 3 or 4 dimension, and we can plot that and we can easily group them for our classification problems. Okay. So then we have another interesting use case is called it as digital twin. So basically, once you started collecting data of these machines and process, you have a good picture of what's happening, what rate they are happening, right? So what if you want to test different scenarios? Okay, so this model, right? So you can convert any data logged from any system, you build it a mathematical model out of it. Then let's say you want to try out the different scenario. For instance, take this supply chain optimization problem. Let's say we have 3 equipments, manufacturing units, each is having different rate of production. Okay, now you have a plan of like what will happen if I push each of the equipment to produce a products at let's say 5 quantity per minute. Okay, so how they will behave. So those things can be, you can't, it's very costly to test this hypothesis directly on the physical unit, right? So that's why the concept of digital twin came, where you have a virtual model of your machines, equipments, and assets, where you can test your simulated scenario and you can test them and you can validate them. And based on that, you find out a right solution, you can then later apply on your real physical systems. So these are the very, like one of the important features in any of the typical IoT platforms. So then optimization of energy and utilities, again, it's very important. Like talking about the sustainability, green buildings, there are so much certifications in the manufacturing, and most of our energy consumption goes to the manufacturing and the heavy equipment operation, right? So we want to minimize the energy consumption of these equipment area. So how can you control it, or how can you minimize it without understanding its without understanding the data, right? So first we will collect the data, we will analyze it, we will try to optimize it. Okay. So then anomaly detection. Okay, everything works smooth, fine. You have a periodic signal of your temperature rising and falling for each day, fine. But what if in some case some anomaly is detected? So we can any type of typical time series data, we can put an anomaly detection on the top of it. I mean, anomaly detection model you can build with that. You can in real time you can predict if there something is there with yeah. Please, Mr. Shankar Narayan, you have raised your hands. If you have any questions, like you can stop me anytime and you can raise, or we have a session, we have a two question answer session intermediately where I can stop it. You can have your questions there. Shall I continue?
Yes, sir, you can continue, sir.
Okay, ma'am. Thank you. So the anomaly detection, then identification of the supplies and inventory management. So what you can forecast your replenishing of the as items and components needed for manufacturing. You can forecast them and you can book them earlier. So then process efficient scoring. So how efficient your manufacturing process are there. Okay. Increasing production speed. Okay. And reducing the hardware sensors. Let's say you are monitoring a vibration level of let's say some heavy machinery. So you have based on your experience, let's say you have installed some 3-4 sensors to monitor vibration level. So with the IoT and data analytics, we can, let's say if you find good correlation with 1 or 2 sensors, there is totally no need for a redundant sensor, right? So using this dimensional engineering, we can physically cut down the cost of the sensors, which will measure the vibration levels, and we can forecast tool failures. Okay. We can track performance, and one very interesting topic which is gaining pickup is the fault diagnosis. So once an error, so in fault diagnosis, basically building a fault tree, is fault tree analysis. There are several techniques comes under reliability and the fault prediction, fault identification and failure corrections. So now people are using ML algorithms to it, and to feed the ML algorithm, you need the right data. So IoT enables this backend data engineering and IoT data consolidation for these machine learning model building. So that's the main purpose of IoT here. So with that, you have a clearer modeling of if one fault has happened, how you can trace it back to what exactly has happened, which leads to a chain of events which occur to this final failure. Yeah. Then you can predict the performance and remaining useful life. So these are the different use cases in industrial IoT. Let's move on to the next section where I'm going to explain what are the different types of analytics are there. So basically, we have like real-time analytics where you can apply some filters and you're using this anomaly detection, other things. In real time, you will validate your data, and if anything anomaly data is there or something way beyond the normal model, you can alert them and you can indicate them to the concerned persons. Then we have spatial analysis. So all these IoT sensors and equipments, they are distributed across your floor plan, right? So what you can do is the data received from one machinery the vibration, other thing, temperature may affect the other one which is close to it, right? So those type of the spatial analytics, which is basically like overlaying your results on top of the indoor or outdoor map for your factory plan, and understanding how they affect each other when they are very close to each other, or how they affect when a system is far from another system. So this type of spatial analysis you can do. For an example, here is some towns distributions. Like you can, if you plot this, you can understand. And very important analytics which we widely used for IoT is the time series analytics. So basically, time series analytics represent the x-axis will be your timestamp data, and the y-axis is whatever the sensor value or other things we are taking. So we want to see the pattern. So most of the temperature, other things follow a periodic pattern, right? So in morning, daytime, we will have a highest temperature, and it will sustain for another 3-4 hours till evening 3 p.m. Then it will just start to drop. So for in typical room temperature, I'm talking about. So, and the evening, like after night 11-12 o'clock, it will go to its least value. So it's a periodic signal, right? So you can fit those things if you are enough data and you have recorded the data for the 1 year like that. You can do some time series and fit a model to it, and even you can do some anomaly detection of it. So time series analysis, descriptive analysis. So we will just summarize the historical data. EDA is similar to a descriptive analysis where you summarize and visualize the history. You have recorded so much data for the last few months or year. Now I want to see what are the things happened throughout this data collection things. Okay, and diagnostic. So why it has happened? This fault analysis will come under this diagnostic analysis, where you will identify the trends and the causation for your failure. And predictive analysis, based on the past data, I mean historical data, you build a model, whether it can be a classification model or a regression model, and you can predict what will happen next in the near future. Then we have other like prescriptive analysis or argument analysis. So yeah, so okay, let me quickly go to EDA now. So we have it's 10:30 now, so we'll quickly move on to the next section, EDA. So EDA, like in the intro, so Liban sir has clearly told that in exploratory data analysis and approach is taken from Wiki. So what it's doing is summarize the main characteristics. Okay, you have taken the data, what this data is going to tell. Okay, what are the main characteristics? You're just taking the summary out of it. That's the sole purpose of EDA. But especially why it is needed for an IoT, because this IoT has different types of data, different timeline, right? So in this case, you may have so many missing data, so many non-important data sets in the columns or dimension will be there. So initially EDA is necessary to identify which are the variables or which are the sensor data is important for our hypothesis or our objective, which are not, or is there any missing data is there? If there is any missing data, how to filter them? So there are so many things to discuss in EDA, but because of the time extension, I will stick to a very simple EDA model, and I will also have a very simple machine learning model built on top of the IoT data. Okay, so it's a EDA process comes under this data science process, where in your physical system you are collecting the data, and the data is processed through an IoT systems, and you do the usual cleaning and filtering of this data, and you do an EDA. So from the basic EDA, you understand what else to be done. Example, for in cases, some cases you need a type conversion, some cases you want to normalize them. So all these understand you then you reapply them in the data processing. Okay, you can see there is a loop back to the data processing. So you can't directly take the data, just filter it, then use it in a machine learning model. Through an EDA, you clean it, you be sure that, make sure that your data is clear, your objective is clear, you understand the distribution of the data, how they are correlated. These are the very important things. Then you feed it to your machine learning model. Okay, and take the necessary actions, like have a very good visualization part of it. Then you take the action that will reflect on your, again, physical systems. So that's the objective of EDA. Okay, so there are several tools and packages, even there are some frameworks available for EDA, but since I'm a believer of open source, we will stick to that. And one of the easiest and quickest method will be like using Python. We have several packages for exploratory data analysis. One of the primary one will be like pandas. So basically pandas is dealing with tabular data set. Okay, when I say data set, basically it is 2 dimension. So you have multiple dimension or multiple columns, right? So for example, take here any data set from your loaded from a CSV file or your SQL file will be of this format. Okay, you have n number of rows. Each row is will be called a data points, and you have n number of columns. Each column is going to, in terms of machine learning, we call it as features, right? It can be for our sensor, it can be each sensor data. Okay, and each column have an homogeneous data type. For instance, let's take a director name, James Cameron Gorgon. Say all these things are string, and we have duration will be a float value. Okay, and the IMDb score is a float value. So like that, each column will have an homogeneous data type. So you can represent any data set in the tabular format, right? So pandas is a very good packages used extensively by the data science community for handling these type of data sets. You can load them directly from your CSV. You can load them directly from your SQL. Okay, even Excel. You can load your data set as a pandas data frame, and you have a lot of data manipulation here, like doing transpose or filtering some value based on some condition, dropping some columns. Let's say you want only IMDb score greater than 7. Yes, you have it's just a single line command to do that. And like you want to drop some 2-3 unnecessary columns. So all these things we can do using pandas. So pandas is basically a data manipulation. So we are going to use pandas in our next walkthrough. Then for visualization, now I have collected the data and did some filtering, removing the columns and filtering all these things. Now I want to see what they are trying to tell. Actually, pandas inbuilt have some basic description like I will explain you later in this presentation, where you can see how the data is distributed, what are the minimum, maximum. So those statistical information you can take from pandas itself. But a picture, I always say that, right? So picture is a very good representation. A graph is a very good representation of the numbers, right? So we will use matplotlib, which is basically a plotting package where we'll plot this data and we'll try to get more insight from our data set. So as lecturers here are aware of MATLAB already, like, so this matplotlib have very close syntax and other thing related to MATLAB. Okay, so let's take an example here. I'm just importing the package here. The first line, import matplotlib. Then I have two dimension, X and Y, two variable. Basically, it's a list. Okay, then I'm plotting it, then I'm rendering it. That's all. It's a very simple packages which is used for visualization. Here I have used a simple line plot, whereas we have other multiple other plots such as bar, pie, scatter plot. Okay, even it supports some three-dimensional plots also. Okay, and the fourth package I'm going to extensively use is NumPy. So this pandas is built on top of NumPy. Okay, so this NumPy are basically array processing package. People who are working OpenCV and other things where the performance is very important, right? So in that cases they will be using NumPy, which is built on top of a C library. So it will be like it's very fast when you're doing array processing, a large dimensional array processing. Okay, only limitation, like we can use Python list also, but the difference between Python list and NumPy will be like in NumPy, Python list supports a heterogeneous data type, whereas NumPy array has to be homogeneous. So all the element in a array has to be of same data type. Okay. And the final packages I'm going to use for machine learning model and evaluation is sklearn, scikit-learn. So the scikit-learn is in our case, it can be used for data analytics, for modeling and predicting. So you build a model like classification and regression model. So basically this built on top of NumPy and SciPy. And what are the things we can do is classification. So you might have aware of like this machine learning has a broad classification of simple machine learning classification and regression, right? So classification you can do, like you can predict whether like let's take our example, whether the room is occupied or not. It's a typical classification program. So then regression will be like predicting some value. Let's say you have a temperature value for the past, let's say 1 year. So tomorrow, what will be my temperature value? So if you want to do that type of prediction, we'll use regression. Then let's say these two comes under supervised supervised learning. Then we have clustering, which is non-supervised learning, where you can group the data based on their related properties. Then we have dimensional data, which is basically in case you have like hundreds of features and columns in your data set, you want to reduce them, you want to see which are the important for your output, then you can do dimensional reduction. So you can evaluate there are so many algorithms are there, starting from naive-Bayes, decision tree, neural network. So you want to run your you want to pass your data set through different models algorithm, and you want to find which one is the best suitable for you. There are model selection functions available in your sklearn. Then there are a few pre-processing like normalization, other things also available. For those, these are the typical processes and packages, sub packages used inside from sklearn. Okay, so without wasting time, yeah, we'll go into the hands-on session. So for the simplicity and ease of use, I have used Google Colab here so that you can open a new tab and you can just start typing what I'm trying, or you can just watch what I'm doing. You can do it later also. So yeah, so I'm going to use Google Colab here. So basically I want to run my Python code, right? So what I'm going to do is I'm going to load my data set and I'm going to apply some, I first try to understand using pandas. Then I will do some advanced visualization, like not advanced. Okay, I'm taking some simple visualization using Matplotlib and try to understand more about my data. Then finally, I'm going to build a machine learning model. Okay, so I can either run on my local machine, which where I have this Python 3 installed on my machine, and I have this all packages like sklearn, pandas, NumPy installed using pip install. But for a quick and easy demonstration, I'm going to use Colab so that you can parallelly try that. So in Google Colab is basically a kind of like VM which is given by the Google, where you can execute your Python in the browser itself. No configuration, no installation, nothing is needed. So people who are aware of it's kind of notebook format where you have this code and the results and text can be all things in a single file. So it's stored in IPYNB file format. Usually all Python files are saved in .py, where you have code and comments, right? Whereas in this case, you can have the results and you can have a text additional description of what you are doing in a Markdown language also. So we are going to write code in code cell and we're going to run it. Okay, I will show you a demonstration of these things. Okay, so let me open my browser. Okay, so Google Colab. So I'm going to create a new notebook. Okay, so this is my page where I have given a name for my project file, and you can write both code and text in this code blocks, and you have a text blocks. In text, you can add description, you can add your HTML and Markdown language description, or you can add images, other things. In code part, you will write your Python code and you will execute it using this button. You can click on it, it will run, and it will show the results or output of this code block immediately next to this code blocks. Okay. So we will start with our exercises. So, yeah. So what you're going to do is we have basically a room occupancy data. So I have taken very simple exercise here. So I have a data set, so which is again hosted in my GitHub. I have filtered it and kept it as simple as possible so that people will quickly get started with the EDA or analytics. And first you try to understand the sensor data file. When I say that it's understand means like what are the different columns are there, how many data points are there, so what are their minimum and maximum values, so what we are trying to find, so what is the final output, what are the inputs and what are the output. So those things you try to understand and you plot. We are going to plot. So critical part of any EDA is plotting with the different various graphs to understand the data distribution and to understand the correlation between these factors. Okay, then what we are going to do is till one and two EDA is over. So basically in 3, what I'm going to do, I have taken a very small data set here. So with that, I'm going to build a model and validate it. Then I will later scale it up for my original data set. So that's just not covered here, but I will, for the introduction purpose, I have a start building a model. Okay, build a decision tree model. There are so many other machine learning algorithms are there, but let me use this simple decision tree model here. Validate my model by 2 different techniques. One is the accuracy score using the test data, and there is a cross validation method where you validate your model using the data you used for training your model. Okay, so few topics maybe a little off for few of us, but try to understand the core concept here. So what we are trying to is we are trying to understand the data set, and we are going to that's the main part of this presentation. Okay, then finally we are going to export that machine learning model, because as most of an embedded system design, some embedded engineer. So what we want is you have a very good machine learning model with very good accuracy. So what is next? So I want to take what the machine learning model has gained and want to translate it into my embedded system, right? So how to export them? So that also we'll see how we can export them into a simple inference condition and deploy in my embedded boards like Arduino, and so that I can start predicting this occupancy in real time. Okay, so let me explain what this data set is. So basically this data set is a room occupancy data. So in a room, I have installed an occupancy sensor, okay, and a temperature sensor and a humidity sensor. Okay, these 3 are there. So temperature and humidity is my input data set, input column, and the output is data occupancy column, whether it is a person is present or not. So present 1, if a person is not there, it is 0. So with that, I have learned, I have trained and I have logged data for, let's say, a few days. Okay, I have few days, I have logged the data, and I have almost like 1,000 data points here. So what I'm going to do now is for another room, the occupancy sensor is costly. Okay, whereas I have only temperature and humidity. So with that just temperature and humidity, is it possible to predict whether the room is occupied or not. Okay, so this is a classical supervising problem where in one setup you have all the three sensors: temperature, humidity, and occupancy, and you are collecting the data. From that, you are building the model and validating. Once your model is ready, you are taking and implementing it on another room where you have only temperature, humidity, and occupancy sensor is not there. But with the trained model from another room, you are going to predict. So you put this logic inside your embedded model. Just with the temperature and humidity data, it's going to predict whether there is room occupied or not. Okay, it's a very simple use case. So first we'll start with loading the data set. So I have this data set in my GitHub repository posted as public. You can download it. It says, okay, then the first line, I'm importing the pandas package here. Okay, similar to your C header, right? So then I have to load the data set from this website. It's a basically CSV comma separated value file. Then I have did three things: df.info, df.describe, and df. I will run it first, then I will explain one by one what are the output of these descriptions. Okay, so let me quickly, I have taken this as a code format here. So I will quickly copy here one by one, then I will show you. Yeah, so this is my first thing. I'm just loading the data set and I'm going to print info. So let me run it. So you can see here, once I started running, Google is allocating some VM for me, and it will give some RAM and storage spaces for this particular instance of Colab. Okay, good. So you can see here df.info. So all our data sets is in our data frame df, right? So df of info will give you information about what are the columns are there. So you can see here there are the 4 columns: temperature, which has 100, and is there any missing data? No, there are no null data, and its type is float 64. Okay, so these things is very important. You have to see the float database. Sometimes even the numerical data can be considered as object or string data type. So in that cases, you have to find there may be some quotation or some additional dot in your data. Like so that kind of thing filtering will come into the first point is data filtering. You have to see, is there any null data is there? In this case, it's already filtered. Okay, for this course, I have not taken that data set because we have very less time, right? So but in practical thing, you will have null characters at some of your rows. Either you can eliminate the whole row or you can fill it with the mean and other values. Okay, and you have to check for the data set, which is very important. So as long as when you're working with the machine learning other places, other than output, it has to be in numerical format. Okay, so in our case, yes, it's fine. They are float values, both temperature, humidity, and CO2 level, and our occupancy is basically actually binary, whether it is occupied or not, right? So you can keep this as Boolean also, but in my case, I have kept it as integer, 0 and 1. 0 means it is not occupied, 1 it is occupied. Okay, so now it is clear. I have 1000 rows. Okay, all data are filled, there is no missing data, and their data types are fine. Good. So we are good to go. So second thing I'm going to take is df describe. Okay, so df describe, you can see here. So this part is the df describe. So it's to give you a statistical summary of your data. You can see we have 4 columns, each have 1000 rows. The average temperature is 21 degrees Celsius with a standard deviation of 1. The minimum is 20, the maximum is 24. Okay, and the humidity similarly, we have minimum 22 to 31%. Relative humidity, CO2 level minimum is 427 ppm to 1402 ppm. Okay, and occupancy is like minimum 0 means it is not occupied, 1 is it is occupied. You can see is mean is 0.35. Okay, so which means that like if we so this give a one understanding that like almost like 35% of the time it is occupied, and 70 balance 65% of the time it is not occupied. Okay, so that's the first insight we are getting from it, but it's better to have a pictorial representation of it than trying to read this data. So first we'll see how good my output is distributed. So I want to predict occupancy, right? So the inputs are temperature, humidity, and CO2. With these 3 input, I'm going to predict the output occupancy. So I want to first see how well this guy is distributed. Okay, for that, it's better to use an pie chart. Okay, So I want to see the occupancy distribution, how good this occupancy is distributed. Okay, how well it is distributed. We have two classes, right? 0 and 1. So what I'm doing here is like I'm importing the matplotlib for plotting because we are plotting here. Okay, this is for styling. You can leave that. You can. It's basically for something like theme kind of thing. Then you assign a figure, a plot which is of 18 cross 6 size. Okay, so this thing is very important. What you can do, what you are doing is remember what are the columns we have here. We have in our data set. So the columns here: temperature, humidity, CO2, and occupancy, right? Inside the DF. What I want is only the distribution of DF of occupancy, right? So that's what I have. That's why I have it here, DF of occupancy, and we have a function method in pandas which will do the value counts, which will it will take what are the values unique, what are the unique values in each of these. So in our case, the unique values are 0 and 1, right, in occupancy. And how many counts are there? 0, how many zeros are there? How many ones are? It will return that. And I take that X as an use that X to plot it here. So that's all. Okay, it's a very simple. You don't have to go to the syntax. So I will advise everyone who are listening here, like it's no need to go deep into the syntax part. Okay, it comes later. You just understand gist of what I'm trying to explain and what you are throughout this process, what you are gaining from your data. So that's very important. So let me plot this here. Again, head function, it's basically show first 5 columns of your data points. You can do that also, but it's not necessary for currently. Okay, let me quickly move on to the next cursor. Let me create a new code block. You can write it here itself. Again, it will rerun it. It's not necessary. So I will go for a new code block where I will run this. Okay. Yeah, you can see here. There are totally 650 out of 1,000. 650 data points have no occupants, and 350 data points have show that it has occupied. So it's better to, instead of a numerically, it's better to have a pie chart where you can quickly understand how well your output is distributed. Then now we will see how the inputs are distributed. Okay, so just plotting an histogram is not going to be useful for us. So what we are going to do is, our target is occupancy, right? So I'm going to, what I will do, I will divide my data. So let's take temperature column. I will take temperature column where the occupancy is not, okay, where occupancy is 0, and have a box plot of it. Box plot is basically a distribution plot where how to read that box plot is basically you have this median line 50%, then we have the 75 and 25%, and we have outliers. These dots are outliers. So this is basically a histogram plot of represented in a different way. So these box plots. So what I did is I divided each column. I have 3 input column, right? Temperature, humidity, and CO2. Each I divided based on their occupancy, whether it's occupied or not. Then I plotted this distribution. Now it's a very good insight now we will get from it. So I will show it in the graph and we'll zoom it and I will show you. So let me copy the code for it. Yeah, so what's trying to say, you can see that there is a difference, clearly a demarcation between your 0 and 1. If both are same, which means that this temperature column has no effect on occupancy, right? So you can see here the temperature value starting from 20 to 24 is there, it is distributed, and a mean average temperature for when a person is not occupied, it is less. Okay, when a person is occupied, obviously we will exhale air, okay, and it will increase to CO2 buildup and also rise in temperature. So you can see that average temperature between an occupied and non-occupied is 20.5 to like almost like 23. So this itself will give you a good visualization or good insight of but just by looking at this graph, you can tell that you can roughly give me a equation, right? So when I ask you like how can you tell with respect to which column is important, you can see CO2 has very good variation when compared to other two, then followed by temperature. Then you can see the humidity has very close mean value in both for both 0 and 1. So this may not be the right guy for our model building, but CO2 and temperature have good clear variation for occupied and non-occupied, right? That's a one good insight. So this, and you can see CO2 has a lot of outliers when compared to humidity. So with that, what we can do is we can choose the right columns. In this case, just a 3 column is there. Imagine you have 20 columns. Based on this graph, you can identify which are the columns are most important for your model building. Okay, so just with this, I can tell that when a temperature is less than 21 or less than 22, then it is not occupied. When it is above 22, it is occupied. Similarly, when CO2 value level is less than 800 ppm, it is not occupied. When it is above 800 ppm, it is occupied. This is like, as a human, based on my understanding and based on the visualization, I am just saying. Okay, so we can use a machine learning model to drill down, and we can give a very good illustration. Instead of 21 and 800 is the demarcation here, 21 is the demarcation, right? So we can fine tune and we can give a very accurate quantitative value here with using machine learning model. That's what we are going to do next. Okay, so before going to that, we will do further analysis also. So I want to see how these data are correlated. Correlate means how they are related to each other. We have 3 columns, right? Temperature, humidity, CO2, right? So how temperature and humidity is correlated. So the example CO2 and humidity is correlated. You can see in all 3 cases they are linearly correlated, right? Like we have a very good spread in terms of temperature and humidity, but you can see here in CO2 versus humidity, we have a good correlation. So basically, the scatter plot has you can plot multiple dimension in a scatter plot. So in this case, you can see x-axis and y-axis as CO2 and humidity. The color represents like the yellow one represents it is not occupied, and the purple one represents whether it is occupied. Okay, in this case, there is not much differences there. In some cases, it will show clear distinction and clear grouping of this data. It might be helpful. Okay, so now things are ready. Now I want to select feature. So I have 3 features. It's fine. I can directly load all these 3 features in my visualization in my machine learning model, right? So, but it's not it's not advisable when we are working with the data with the larger data sets. Okay, so in that case, you want to find out which features are important or which features have clear distinction of this output occupancy, which is most important. So to identify that, there are some inbuilt functions called angle curves and parallel coordinates. So one simple thing I will take is parallel coordinates. Parallel coordinates is basically a function from your pandas plotting. So what I'm doing, I'm just taking a copy of my data frame 1. So I'm going to see how these data are, how these columns, right? Temperature, humidity, and CO2 column have distinct distinction for this occupancy output. So first I have to drop my drop means I'm dropping that column, occupancy column, and I'm storing in the a separate data frame called df plot. And this part from for to inside this for code block is basically normalization, because each has in different scale, right? Temperature is having from 21 to 24, whereas humidity is from 40 to 80. CO2 is in some 400 to 1400 RPM. So I want to plot it in a single graph. I want to normalize it. For normalization, what I do is I'm calculating the minimum and maximum value, and we use this typical subtract by minimum divided by the range, maximum minus minimum. So basically, this for block is only for normalization, so that bring everything to the scale of 0 to 1. So that when I visualize this, I will clearly have a picture of like what exactly how well they diverse my occupancy data, the output data. Okay, then I apply on my parallel coordinates function and I will plot it. So these graphs shows. So let me just quickly show it in the collab here. Okay. So okay, before that, I will have something called heat map also. Like correlation plot is basically a scatter plot. We can do that. There is another called a heat map also. We can do. I will show you that part first. So basically, this heat map, it's trying to say what is the correlation between these each of these variable. But as you can see, I have dropped the occupancy. Even you can try that also. So let me just comment it first. First, I will have all variables, all 4 variables, temperature, humidity. So first, let me run this. Okay, now what you can understand from here is the white one is one means high correlation. So obviously, each variable occupancy with respect to occupancy is going to have one correlation factor of 1, right? So this diagonal is always correlation factor of 1, and you can see 0.95. 0.9 means again it's a very good positive correlation, and the dark ones are almost close to 0.5, which has not good correlation. Sometimes it will, in some cases it will go for -1 also, which shows negative correlation. In this case, these are negative correlation inversely proportional. positive correlation directly proportional. Okay, so you can observe that like let's take occupancy, because occupancy output, right? You can see occupancy have these three colors, right? So these are almost like green. The highest one is, you can see this color is around 0.8. The dark one is 0.6. We can leave it. Again, the purple one is 0.7. We can the color with the column with the highest correlation is 0.8 against CO2. So this graph says that CO2 value has very good correlation with the occupancy when compared to other two. Okay. Now, so this is the one understanding from this. So what are the other understanding you can see here? Like how about these three guys react to each other? Okay. Now we know that our output has very good correlation with CO2, which means that just CO2 column is enough to classify our occupancy. So what about others, other two with each other? Okay. So that's why I have used this part where I have dropped my occupancy and only used these three columns. Okay. You can see that from the same graph itself, but just for the sake of zooming visualization, I have removed that part. Okay, now you can see this 0.95. So this one, humidity and CO2 has good correlation when compared to the temperature. Okay, it falls below 0.8, like almost close to 0.85. Okay, so these are the observation you can make. How well your dimensions. Here is a very simple data, just a 3 input column, 1 output column with just 1000 of data. Imagine you are using a large number of data with large number of features, then it will be like you will get better insight of your data. Okay, so yeah, moving on, I will try this parallel coordinates. Okay, again, the same thing is parallel coordinates try to represent, like it's going to show all my red lines are non-occupied, or my green lines are occupied, right? So which column is having clear distinction of red and green? You can see temperature almost green and yellow are overlapped, right? So which means that this guy is not good enough to distinguish between 0 and 1. Humidity, yeah, it has better distribution, but you can see there are few red lines in the green zone, and there are few green zones in the line. And compared to these two, CO2 has very clear distinction between occupied and non-occupied. I mean, I'm just representing different format of what we have seen here as a box plot, as a correlation heat map, as a parallel coordinates. Okay, so everything it's keep on telling us that so CO2 is far better than another two guy. Then followed by CO2, humidity is a good factor to consider for our machine learning model, which classify our whether room is occupied or not. Okay. So now that's all the EDA part. So these are the EDA will give you hypothesis. So what is our hypothesis? How we are going to model your room occupancy using a machine learning model. Is it possible with the temperature, humidity, and CO2 level? Is it possible to augment? Yes, it's possible. They have good correlation factor. So out of these three, we observed that through EDA techniques and plotting, we found that CO2 has so far, like when compared to other two, has good correlation and easily clear distinction for whether a room is occupied or not. Okay, now our EDA part is over. We can do a preliminary machine learning model building so that we can feed it back to our embedded systems. Okay, so what I'm going to do now is I'm going to split the data. Okay, the reason I'm going to split the data is to validate my results. Okay, there are several ways, there are several scores. Okay, like to validate a model, like F score, confusion matrix, so many other things are there. I'm going to use two techniques. One is using accuracy method using this test data. The other one is cross validation. So these two, I'm going to validate my model. So first, what I'm going to do, out of this 1000 data, I'm going to take randomly, I'm going to shuffle and I'm take 750 rows randomly to train my model. I feed that data sets to my machine learning model. I will build my model. Now this model has no aware or knowledge of this remaining 250 data set, right? Did 250 rows. So I will use that test data to evaluate it. So because for these 250 rows, I know what is the output, right? Occupant or occupant. Now I will just hide that occupancy data. I will feed that to my model, and I will see what is the result this guy is telling, and I will compare with the known result, and I will with that, I will conclude with the percentage, how much percentage the model is accurate. Okay, so this is a very good and very one of very important validation model for a simple machine learning algorithm. Okay, so the first part is splitting the data. So I'm going to split my data. So going back to, we have a ready-made function for that from sklearn model selection called train test split. So let me copy it. So how are we going to use this function? So in my, so this is a typical representation. So X represent my input. What are my inputs? Temperature, humidity, CO2. What are my outputs? Just occupancy. So what I'm doing is I'm dropping my occupancy data. If I drop the occupancy from my DF, so what is other three will be temperature, humidity, and CO2, right? So that will be stored in XML. So I'm convert my pandas data frame into NumPy array. So because most of the machine learning algorithm will take only NumPy array. So to convert a data frame into NumPy array, use dot values method. Then similarly, only the output is taken in Y. Now we have X and Y, right? So we are going to split it using this train split function. So you feed in X and Y to it, and you tell how much will be the text size. So 0.25 represent 25%. Right? There are 1,000 data, right? 1,000 rows. To 25% of 1,000 data is 250 data. You take it as test. So it will be stored in Y test and X test. The other 750 will be taken in X test, X train and Y train. Okay, input in X, output in Y. So this will be randomly shuffled and taken. You can set some random state value. This is I have set to some value. This is like basically to replicate the results when I'm trying next time. It can be any values, random state, or it's an optional. You can leave this. Okay, so once it is taken, now I'm going to see what is my size, or what is my shape of it. Shape in the sense how many rows and columns are there in X and Y train, and similarly X test and Y test. Okay, let me run it. So you can see here the training data contains 750 rows and 3 columns. So remember the 3 columns are temperature, humidity, and CO2. And similarly, the output Y train contains 750 rows and 1 column. Okay, so if it is nothing, it means 1 column. Similarly, the test contains 250 rows, 3 columns, and 250 rows, 1 column. Clear? Now we have clearly splitted, and our data is inside X train, X test, Y train, and Y test. Good. Now we are ready for building model. So for building model, which data set we will use? X train and Y train. Okay, let's go ahead. Okay, let's going to use a model creation. So it's very simple in Python. Like we have so many classical machine learning algorithms like naive Bayes, decision tree, even bagging and boosting algorithm like random forest and other things, neural networks. Okay, I'm going to use a simple decision tree classifier here. So let me take it here from this one. Okay, so I'm loading the decision tree model. Okay, number one, I'm first initializing the machine learning in decision tree model I'm creating. So in that, there is a fact, there are so many other things like entropy and things. Just for sake of simplicity, let me keep just one variable, maximum depth. Basically, decision tree is something like an inverted tree kind of thing where you have nested if-else conditions. Where you will check whether the CO2 level less than 200, then check another if-else condition, temperature greater than this thing. Then finally you come whether it is occupied or not. So what is the maximum depth, the maximum number of levels in your tree? Okay, so that you can give. So initially, let me start with 3. Okay, so I'm going to fit, or I'm going to train my model with the training data. That's all, just a single line. Okay, now the model is ready. So what is the second thing? I'm going to evaluate it. So I want to see how good this is. Okay, so you have loaded the data set, trained data set, and you have checked it, right? So there are several ways to evaluate a model. So for our case, like I'm going to use first one is using the test data. Remember, we only used train data to train our model. So I have my 250 rows and 1 column in my X test. So I'm going to use that to validate my model. So to ML model dot score X test comma Y test. Now what it will do, it already know what Y test is. Okay, X test, it will apply on the machine learning model. The output is compared with the Y test, and it will give a consolidated how much percentage of things are true positive. Okay, so that data it will return. And the second one is cross validation method. This is the second method of evaluating your model, where you use the whole data set and you run it for 5 times and you see the CV score. So basically, these are different models. Let me just focus on this machine learning model. Okay. Okay, you can see that it has accuracy of 88.4%. So with the unknown data. So it has only trained using trained data. When you apply test data, it has correctly identified whether it is occupied or unoccupied, 88, with an accuracy of 88%. In most cases, like the CV score is cross validation score, which is another way of evaluating a model, which we ran it for 5 times. Each time it gives 0.9, 0.9, 90%, 91%. So it's as a machine learning engineer or as an IIT engineer, it's your decision whether we want to go ahead with this accuracy or you want more accuracy. So you can add more columns or you can use different machine learning algorithms with different parameters. So that's in your hand. Okay. For our class, for this class, yeah, this will be fine. Like I'm okay with this 88% of accuracy. Now we have our model. So as I told earlier, like I want to translate what this machine learning model is learned here to my embedded board. So I want to convert this tree into an if-else condition, right? So first let's see the tree. So now I want to visualize this ML model. Okay. Yeah. So we can use this export graphics package. Here I'm just converting my model into a figure, a plot. Okay. So it will be like this. So you can see here what we're trying. First, it is checking CO2. Remember the measure of the parent leaves, you can see CO2. You know the reason, because we have seen that CO2 has very good distinguishing feature for classifying occupant and non-occupant, right? So first, remember I have given the value like CO2 less than 800, whether it is occupied. If it is above 800, it is below 800 is non-occupied, above 800 is occupied. You can see the machine learning model have a better threshold value for that. So it will check first whether the CO2 value is less than 724. If it is yes, it will check it again, CO2, and it will again check it for CO2 and temperature. And then finally, the class 0 means non-occupied. Class 1 means occupied. So what you can do is you can see out of 261 values falls under this category, 125. So what you can do, you can prune them. We have something called prune it. Okay. I don't need such so many if else conditions. I want only few if else. You can see one if inside this, if we have two if else condition, and inside each of these we have another. So 1, 2, 3, 4, 5, 6, 7. There are 7 nested 3 levels of if else conditions, right? So you can, what you can do is you can remove them by using this pruning method, or what we call it as you can change the maximum depth. So first we will try this, then later we will reduce that. Okay. So first let me plot this. Yeah. So you can see here we have got the result. Now I don't want such 3 levels of the things. I want just maximum depth of 2 is sufficient. So we'll just change it. You please note on the accuracy is now 0.84, 88%. Okay. So let me change the depth to some 2. Okay, just 2 level of tree. I will rerun the code from here. Now you can see from 88 my accuracy is to 86. Fine, because with the cost of my computation complexity, I'm reducing the accuracy by 2%. For me, it's fine. Okay. I will rerun and plot the graph again. Now, yeah. Now you can see just 2 levels. Okay. You can see it's totally removed these 2 guys. Temperature and humidity is not even needed. We just check for a CO2 level. If it is true, again check whether it is even this can be grouped. You can see here the class 0, both cases class is 0, right? In this case, both are. So you can totally eliminate these guys. So you can clearly say that when CO2 level is less than 724, it is not occupied. When CO2 level is greater than 724, it is occupied. That's all. So you can easily put this logic in your embedded board, and you can start at any for we assume that the rooms are identical, because this is data collected for a one room. The logic we learned from here, we are going to apply an embedded board and going to test it on another room. We assume that both are identical. Okay. So further improvement to the accuracy, all these things can be done by trying out different algorithms, different machine learning models, and also doing a lot of adding more variables. Okay. So yeah, so that's it from my side regarding the EDA walkthrough. So we will spend some time on discussing. If you have any questions, we will discuss another 5-10 minutes on that. Then we will move ahead with the ISL offerings. Please, we can spend another 5-10 minutes on questions. So please ask your question. Do you have any questions, anyone? Like you can post it in the chat box also. Okay, so there is a question from how do we trust the data from IoT sensor? Okay, so let me rephrase it. Or are you talking about like what are the security measures that can be taken for the IoT sensor data? Because like we are collecting, there are different level of security measures. Okay, it will start with you can do in the edge gateway itself. You can do things called whitelisting and blacklisting. Okay, you can tell that only collect the data. Let's say you have some different sensors. Okay, so each sensor is having an unique ID. Let's take a Zigbee network, something kind of thing. Each will have a unique MAC address, right? What you can do is you can whitelist at your edge level. Don't take data from every Zigbee sensor which is connected to my channel. Only take data which is from these MAC addresses. So in that way, you can validate using whitelisting method. You can validate it. Similarly, when you're sending data from gateway to server, you can use some authentication tokens. You can use some, let's say if you are using MQTT, you can use MQTT authentication. Okay, and even they support few of the other protocols like QAP, other things support encryption also. So you can encrypt this data and you can send it to your cloud. So in that way, from sensor to the cloud server, you can ensure that the data is exactly from that equipment or that measurement you are taking down. So in that way, you can ensure the security of your data. So, okay, second question from Arun Kumar N is the quality of data, whether it varies from sensor to sensor. Yes, so obviously this we are logging this cyber physical system, right? So we are taking these things and systems and process in the physical world, and we are collecting this data to our cloud and server where we do the analytics other things. So this it will vary purely depend on the sensors. Okay, in some cases you might be needing you may be needed IP rated. So it's a pure and hardware embedded embedded perspective. The resolution and accuracy of the sensor depends on the how good it is, how depends on the manufacturer, depends on the calibration, other thing. But few things can be done at the software part also. Okay, so you can validate them because the chances are that due to some short circuit or something, sometimes you may get a very random data. Okay, your system must not take that as a temperature data. Suddenly temperature data will, let's say an ambient temperature, suddenly it won't go to 100 degree or something like that, right? So you may put in some intermediary validation for your data at the edge level itself, so that it need not be unnecessary positive or cloud. So if sudden changes in temperature, so those things are never going to happen in your ambient environment, right? So in that cases, you can put such checklist, such validation at the edge level itself. So with that, you can maintain the quality of data. So first question was like about the security, or how good we trust the data. For that, you can take different security measures. And the second question we answered is like about how good the data is, how quality it is. For that, we have to use multi-level validation for your data. And use right sensors with a good measurement range, and use calibration, regularly calibrate those sensors, and have record protection and safety precautions taken when you are collecting the data. Any more questions? Then we'll spend another 5 minutes maximum. Then I want to spend some last 10 minutes on our organization's capabilities and offerings on IoT.
Participants, if you have any queries, you can ask.
So like if you have any question later also, like I will share my email ID at the end of this session. You can contact me anytime. You can please drop an email, explain about what are your questions, and what are any of our IoT offerings. Also, if you have any questions, you can directly inquire in our website, and also you can ask us directly. So my email ID will be displayed, shared with you at the end of these sessions. Okay. So So shall we move on to the finals, please?
Yes, sir, you can move, sir.
Okay, fine. Thank you. So, yeah. Okay, so another few minutes, I will explain about what as an services we are going to offer, what are our capabilities and service offering. Let's start with who are we. Like we have past 25 years working as a customer support technology partner, and we have several working most of our solutions on IT infrastructure, security and risk management, and primarily working on digital transformation of industries, especially on banking and automotives. So our InSpaces offer is centered at our headquarters is at Chennai, and we have distributed across India several centers, and we are part of COC Holdings from Japan. So we spread across 5 countries with customers of over 600 and total employees of 2,200, and we have additional employees deployed our client locations also with 9 regional offices. So what are the practices we have been taking? So first main practices in InSpaces are infrastructure and cloud. We have this data center solutions, network solutions, tools and automation solutions, cloud management, cloud infrastructure services. Those are our primary practices. Then we have a risk and network security and risk services. We have our IoT. So I'm part of an IoT team where we do this hardware design, development and prototyping. We do a lot of embedded design, circuit design, deployment, testing, validating of our IoT solutions. We have web developers working on this IoT backend monitoring system and also the front-end visualization part of it with analytics and alert systems. So other solutions involved, we are working on banking sector. We have business intelligence team who are working on AI, RP is one of the stronghold of our teams, and followed by product development related to cloud, mobile apps development, and also we have worked in data analytics, AI and ML. So we have a separate team for automotive where they are working on projects and projects related to purely or related to automating with the testing and validation of testbed for electric vehicles. We have embedded and software development team particularly for the automotive domain. So finally, we have a warranty management section where we'll take care of this hardware and infrastructure. So these are the different practices of InSpaces Solutions Limited. So since our main focus on Internet of Things, so IoT, we have our solutions will involve a dashboard visualization, identification of key parameter understanding, and real-time data feed. So then we have a custom solution. So basically, each customer have different requirement, different use cases, right? So we will discuss with them. We will translate their user requirement into technical specification. We have a big team here with comprises of back-end, front-end engineers, hardware engineer, edge developers, with the people from analytics and machine learning engineers. So we'll sit together and we will formulate the use cases and POCs, and we will give you a very customized solution to our customers. So what exactly they want? We have several projects successfully completed in the past few years. So which will cover starting with the understanding their requirements, then identification of sensors, like what are different sensors is needed, or how can we access the data from their systems, okay, with our edge gateways. So then how to communicate from sensor to gateway and gateway to the cloud. So typically from cloud to gateway to cloud, it will be either it can be an web API using HTTPS, or we will use a security MQTT. When compared to and communicating from sensor to the gateway, we have used wired, Modbus, TCP, Profibus, Profinet protocols, both Modbus, RTU and TCP, and also we have a few of our projects we have used LoRa, Wi-Fi, and Bluetooth and Zigbee modules. And some cases we have used a 4G network directly, where instead of communicating to the gateway, our sensor will directly push the data to our cloud server. Okay, so and cloud platform. So all this data is getting consolidated in our cloud platform, right? So we have both the solution. We have our own hybrid. We have our own cloud server, or in some cases, if a customer wanted to be loaded into an AWS Azure, yeah, we have that solution also. Or the third option, they want their on-premises IoT platform, like they want the whole complete platform which will consolidate the data, which will store it, which will have visualization analytics, all these things in their PC, their machine, their server, which can be accessed intranet in across their industry. Yes, it's also possible. We can we have did few of our deployment there also. So our basic this IoT platform development is our core. where we use this NoSQL database a lot, because most of these IoT data sets are unstructured, right? So, and we have several services like visualization service, analytics service, edge service, validation services, machine learning services. So we have different these services communicating with each other, running parallelly, which can be easily scalable across in horizontal domain. So we use this distributed systems. We extensively use Python, Java, and other programming language to build our IoT platform. Yeah, so analytics engine, once data is consolidated, collected from the edge, brought to the cloud server for database storage and visualization and alert. Okay, so first data collection from a sensor and gateway, then storage in cloud. We have data storage and visualization, whether it is a web dashboard or a mobile app. Yes, it's possible. We have that. Then we have an alert system, because most of these IoT applications, they want a alert in the terms of SMS, push notification, and periodical summary, like every day what has happened, what is the minimum, maximum, is there any anomalies other. So these will be templatized and sent to the respective stakeholder every day at the end of each shift. It's possible summary. So these are the what has happened. Then what's going to happen can be covered in the part of like analytics engine. So all these millions of data points with these things, whatever we discussed, right? The analytics, different types of analytics. We have dedicated analytics team for that to do the forecasting, prediction, modeling, depends on the customer's requirement. So a typical this IoT platform, we can classify into three things, starting with the edge, okay, where you have this communication of the data from sensor to the edge gateway using different protocols. And we added so much security layer on the top of which, like secure booting, encryption, whitelisting, so all these things. And these are hardware agnostic, which means that we can use any off-the-shelf available edge gateways, or we have a few of our edge gateways successfully deployed in few of our customer also. Okay, there we can do a little bit of validation also in edge framework. Then we have device management platform, because we are talking about hundreds, thousands of any typical, even a small application, we are talking about hundreds of devices. I'm not talking about sensors, because each device may contain multiple sensors, right? So how these multiple devices you are going to manage? In some cases, you will be having vibration collection unit, in the other case, you have temperature collection unit, right? So for these devices, how you are updating the firmware using OTA, whether you're giving an ID and unique, and then we want to remotely monitor their connectivity. Okay, and not just to support collecting data, there are so many things are there, rebooting them. So all these things we can directly work with the device using device management platform. You can add and you can remove a device, you can update a device. Then finally, we have a cloud-based IoT platform, where all these distributed microservices architecture are integrated and rolled out as a single solution, which involves visualization, alerting, and analytics part. Okay, so these are the major classification of our IoT platform. So what are the things we are offering? This is very important. So we have these consultation services, where we will identify the digitization IoT roadmap, and we'll develop a POC for our end customers, particularly on IoT, industrial IoT domain. And we architect service. So what we can do, if we have a problem or a solution, we will formulate a solution with what type of, we will go for a market survey. We'll identify the devices, sensors, actuator, based on their requirement, like what are the measurement range, what a resolution they are expecting. So based on that, we will identify sensors and actuators. Then we will identify the right communication protocol for them to our edge gateway. We'll identify the right edge gateway for this, depend on the availability. Because in some cases we have internet connection, some cases are very remote places where we don't have a 4G or any communication model. In that cases, we have used LoRa. Again, that depends on the distance between the sensor and edge gateway. So all these things we have the different layers of architecture design. Then this ecosystem, once these things are ready, how to deploy them with the cloud analytics, the UI, because each company has some customized their own UI in both as a web and a mobile app, right? So we will do that. So in terms of security, scalability also, we will take care of it. So we'll use proper load balancing things and other things so that it can be easily scalable. Any number of users can access our services at a single time, and you can use it. We have other platforms also integrated with our project, because some of the customers may require our systems to be deployed on their Azure systems, right? Azure and AWS things. So we have a partnership with Continue, and we will work together. Okay. So yeah, so these are the service offering. So we can test the system. We can build a security modules on the top of the system. We will also give support for any existing or new ongoing services related to our IoT. And also we can identify this data analytics and machine learning for our IoT data. Let's say you already have your IoT system there. You want to identify key patterns, you want to identify KPIs, we can do that also. So these are the extended services done on the in the domain of IoT by Inspiracy Solutions Limited. So yeah, so this is a typical energy management system for typical for an industrial things where like we have different assets, right? Like water flow, glass flow, steam, electrical things. Right? Then we have data sources, we have our sensors, we have input, raw input from a flat file, or we can connect it to their ERS system, MES system. Then the second layer will be how you are communication this data to your server using some physical protocol. Then in gateway, in some cases for a critical system, we can put a analytics and gateway in the edge itself. Okay, so then the final part will be our visualize our cloud server, where you have a web UI and a machine learning model, where a data like where you contain all your cleaned and filtered data sets. Okay, and you can this is a device management part. Okay, where you can identify, you can modify, or you can set some configuration for each of these devices. So this is a typical IoT platform. So okay, so we have few use cases successfully completed in the past few years and deployed, and they were successfully running for the past few months. So we have very good projects deployed there. So few of them are like freezer monitoring systems and commercial IoT application where the vendor want to deploy our sensors across India. So we have 3,000 sensors deployed across India. So each of these sensor is monitoring a freezer temperature. So it has to be kept within a limit of minus 10 to plus 10 degrees Celsius, sorry, minus 10 to plus 5 degrees Celsius. So once it crosses that, it is battery operated and it will take power from their mains. So even the power is cut down, it will hold, it can monitor for another 2 days. Okay. So this data, both the battery level and temperature value, it will keep on sending for every 15 minutes. It will send it to our cloud server. We have a validation and alert mechanism, our freezer monitoring unit. So if its values go beyond 5 degrees Celsius, it will monitor only the concerned persons, concerned technician dealer who has deployed it, and also his immediate superior. We have a vibration monitoring for exhaust fan unit. So in manufacturing unit, we have this very big industrial exhaust fan, which is very critical for their manufacturing process. So what they want is they want to monitor, they can't afford for their failure, right? So they want to monitor it. So we have installed vibration sensors. We have attached to this exhaust fan at 2 places. For each exhaust fan, we have connected the sensors to one at the housing and coil unit, and we continuously monitor its vibration value. So we will see the trend, how it behaves with respect to time. We also set alert on top of it, where when it crosses beyond a value, it will immediately alert the concerned authorities. So these are like typical monitoring systems. So we have other things related to IoT, where digitization. So packaging, assembly, design, basically here each station a component is packed or assembled. Okay, so they want a traceability. The main challenge is traceability. Okay, it passes through a 5 station. Each station, one technician will assemble it. Okay, then he will pass it to the next station. He will assemble some other 2 or 3 components. Then it will go to the final station. So if a failure occurs, so the whole product is wasted. So they want to trace it back to the at what time which person or which part is used to it. So for that we need a traceability, right? So we used QR codes, reader and QR code scanner and QR code printer in each of these stations, where all the assembly components are digitized and they are noted, they are recorded, and whenever a person or technician is assembling it, at what time, who has assembled it, those data is it will get logged. So next time when you want to trace it, you can easily trace back to the particular time and particular person. You can use these data for further quantitatively validating the production performance of each of the station or also the technician in the shift. Okay, then we have an asset monitoring system. Basically, each of these any typical building have a utility building, right? So which will give both the HVAC and electrical supply for the main building. So this for operation of this main building, this HVAC and electrical system is very important. So basically, this electrical system consists of batteries, diesel generators, whereas HVAC consists of chiller, AHU units. So these assets we want to monitor. So what we do is we connected our sensors. We connected our edge gateway directly to these assets. So these assets are already industrial IoT compatible. So they can send data such as like its performance and health metrics. It is consolidated and visualization dashboard. Like so, these are the very similar thing we have for energy monitoring, and we also extensively use quickly complete it. Okay, so we have energy monitoring, and also we have smart farming, where we are using this machine learning mobile phone based application to capture this leaf, okay, infected leaves, and it will be uploaded to our cloud server. We have this image processing and machine learning service, which will run and will identify the plant first. Then it will identify what is his health status. And third, it will also give suggestive corrective action also. Like what are the things? So you can say that this is the, let's say, brinjal leaf, and it is affected by this type of disease, and what is this quantitative assessment of how much the spread it is. Then for that, what is the solution, which fertilizer or which pesticide you have to use at what amount. So this also it can be done. So we have this identification of diseases we have completed. Okay, and finally the production performance, which is similar to assembly and digitization, where we monitor the production of each of these CNC machine in a manufacturing industry, and where like each shift they will set a target for a person, right? So this machine, this shift, you have to complete 500 jobs. So how much he has completed, how much yet to complete. So all these things will be logged. We have a backend integrated system with their MES, and it will show as a simple dashboard for them. So these are the multiple use cases we have deployed and successfully running on our clients also. So yeah, thank you very much for your time. So if you have any further, because we already it's 11:30, if you have any question, feel free to reach us at inspices.com using, or you can directly mail me to Shamsuddin or Jalaluddin@inspices.com. You can also please go through our website www.inspices.com. You can find a lot of information related to our other verticals, practices, and IoT stuff. Okay, so yeah, that's all from my side.
Thank you, sir.
Thank you.
Participants, the feedback link has been posted in the chat box. You can kindly fill it. Thank you, sir, so much for your informative session. Now I would invite Mrs. J. Shobana, Assistant Professor, MCA, to propose the vote of thanks.
Happy morning to one and all present here. It's my pleasure in delivering vote of thanks for this day 12 session of this 2 weeks online international faculty development program on the era of change, recent advancements of machine learning in terms of AI and IoT. Our today's topic is Introduction to Exploratory Data Analysis on IoT Data. On behalf of Department of Computer Science and Applications, I express my gratitude to our guest speaker, Mr. Shamsuddin, Senior Engineer, IoT, Inspices Solutions, Chennai. Thank you very much, sir, for a highly informative presentation. Your presentation gives us deeper insights into data analysis on IoT data. I express my sincere thanks to our management and HOD for their motivation and support. I also extend my thanks to faculty coordinators and participants for their cooperation. Thank you all.
Thank you, ma'am.
Thank you. Thank you very much, madam.
Thank you, sir. Participants, we will meet tomorrow for the next session by Dr. P. Susindran from NIT Trichy. The topic is AI for healthcare. We will meet around 10 o'clock for the next session. Thank you, participants.